Alright, let's look at the practice exam 2, problem number 11. Alright, so we want to use the Gram-Schmidt method to find orthonormal basis vectors from this given vectors A, B, and C. Right? And remember that orthonormal means that this is just means that the vectors has to be orthogonal, and they have to be unit length. Right? So this is what this means. Right? So let's do that. The first one is pretty easy because all you really have to do is rescale it so that it's a unit length. All right. So let's call it E1, first vector. All right. Simply, you can take the vector A. All right. And since it's the first vector, we don't have to worry about the being orthogonal to anything because there's nothing else. So we can just divide by its own length. So the norm of the vector A, right? So vector A is given to be 6, 0, 0, 0, 0. And then we're dividing it by its length. So it's a square root of 6 squared, so 36, plus 0 squared is 0, plus 0 squared is 0, plus 0 squared. Right? So this is simply this guy right here is a square root of 36, which is 6, right? So this is just 6, right? So divide 6, 0, 0, 0, divide by 6 is going to be simply 1, 0, 0, 0, 0. Right? So this is the first vector, basis vector, E1. Right? Then we want to create E2 using vector B. Right? So first thing we need to do is take away the component in the direction of E1. Right? So take away the B component of B in the direction of E1, so that B wouldn't have the components of that anymore. All right. So we start with B. So vector B. Right? Then we take away the component of B, so vector B, in the direction of E1. Right? Then of course you have to multiply by E1. Right? Right, so this will give you the component of B in the direction of E1. So we're going to take that away from B. Right? So if you compute that, B is 1, 0, 2, 0, and we take away, right? So B is this matrix, a vector. So you have 1, 0, 2, 0. We take the dot product with E1, so which is 1, 0, 0, 0. Then you multiply, so this is going to be a constant, and then multiply by 1, 0, 0, 0. Right? So what you get is actually, let's see, so you have take the dot product of these two, and we get this, right? So this is actually just going to be 1, right? Because it's 1 times 1, 0 times 0, plus 0, 2 times 0, 0 times 0. So this is going to be just 1, right? So what you get is, maybe I can go here. Right? So we have the 1, 0, 2, 0 minus 1 times 1, 0, 0, 0. So it's going to be 1 minus 1. So you're going to have 0. All right? Then you have a 0 minus 0 is 0, and 2 minus 0 is 2, and 0 minus 0 is 0, right? So since we took away the component of b in the direction of a or e1, so this vector is going to be now perpendicular or orthogonal to e1. You can take the dot product. Obviously, dot product is going to be 0, right? So in order to construct the e2, right? So we already have a vector perpendicular or orthogonal to e1. So we just have to make sure that this is the unit length, right? So you're gonna have, right? So you have 0, 0, 2, 0 divided by square root of, right, 0 squared plus 0 squared plus 2 squared, so it's 4, and plus 0 squared, so you just have that, so that's 2. So if you do that, you're gonna end up with 0, 0, 1, 0. Right? So that's the second basis vector. Right? Now it's nice and unit length. Alright, then the third one, so since we already have two vectors, we have to take away the component of c in the direction of e1 and the component of c in the direction of e2. To make sure that it's the orthogonal to e1 and e2. All right, so we're gonna get c. Right, we have c. We take away the component of vector c in the direction of e1. All right, and also we're gonna take away the component of c in the direction of e2. All right. So what you end up getting would be, all right, c is 4, 1, 9, 2, right? Minus, right? Let's do the dot product. So dot product of c with e1, which is here, which is going to be 4 times 1, 4, plus 0, plus 0, plus 0. So it's going to be 4. And times e1. E1 is 1, 0, 0, 0. Right? Minus. Right, now we take the dot product c with e2. So c with e2, you see that 0 plus 0 plus 9 plus 0. So it's going to be 9. Then multiply by e2. E2 is 0, 0, 1, 0. Right? Then you will see that this vector would have, let's see, 4 minus 4, so that will be 0 here. Right, 1 minus 0 minus 0, so it's 0. Right? Oh, sorry, it's 1 I meant. Right? Right, next component of 9 minus 0 minus 9, so it's 0. Right? Then 2 minus 0 minus 0, so it's 2. Right? So the last thing we need to do is make sure that this is a unit length. So you have E3 is now, right? So you take 0, 1, 2, 0, 2, 0, 2, right? Divided by its length, which is going to be 0 squared plus 1 squared plus 0 squared plus 2 squared is 4. Right? So you will get 1 over square root of 5 times 0, 1, 0, 2. Right? So that's the third orthonormal basis vectors. Right? That's it. So this is called the Gram-Schmidt method, and you can see that these are all orthogonal. If you multiply, take the dot product, then dot product is always 0, and each vector is of unit length. All right, that's it. I hope that this was clear.